Welcome YouTubers to another episode in my Grammar Hero series. In today's video, I'm going to show you the solutions to the Mathematics Knowledge subtest of the first practice test on my website. In case this is your first time finding one of my videos on YouTube, I recently created a website called mastertheasvab.com. There you can take 3 full-length practice tests as well as estimate your AFQT score. That said, let's go ahead and get started with today's video. Question 1 says half the cube of 4 is. So mathematically speaking, this is what that looks like. Half of the cube of 4. We want to find out what that's going to be. Now this looks like this. 4 cubed is the same as 4 times 4 times 4. 4 times 4 is 16. In case you can't do 16 times 4 in your head, that looks like this. 4 times 6, of course, is 24. Carry the 2. 4 times 1 is 4, plus 2 is 6. So this is 1/2 times 64 equals. Now we can regard this as two different ways. We can regard this as 1/2 times 64, or we can go ahead and do this. 64 over 2 equals. And instead of regarding this as a fraction, we could read this as 64 divided by 2. That is long division, which looks like this. 64 divided by 2. In case you can't do this in your head, we have to ask ourselves, how many times does 2 go into 6 without going over? Well, 2 goes into 6 evenly 3 times, and 2 goes into 4 evenly 2 times. So 2 times 32 will get you 64 with no remainder. So 64 over 2 is the same as 32. Therefore, we know half of the cube of 4, which is the same as half times 4 times 4 times 4, or 4 times 4 times 4 is 32. Okay? As I work through these problems, I just want to say this. This first practice test is one of the easiest practice tests on my website. So if for some reason you breeze through this section, go ahead and take the other practice test. Those questions in the other practice tests do get a little bit more challenging, especially the third practice test. Okay, question 2 says, if the radius of a circle is increased by 3, their circumference is increased by what? And we're given 3 pi, 6 pi, -3, and 6 as our answer choices. Whenever I'm presented with problems like this one, I like to go ahead and actually assign real numbers to the hypotheticals. So we have one circle, and we have a bigger circle, and we're being asked what happens to the circumference when we increase the radius. So right away, I know that I'm going to need to jot down the formula for circumference, and that's circumference equals 2 times pi times r. Okay. The other formula for circumference is pi times diameter. If I was given, I wrote r radius there. Pi times diameter. If I was given the diameter, I would use this formula, but since they gave us the radius, I'm going to go ahead and use this formula. And specifically, we want to find out what happens when we increase the radius by 3. So if I let this radius be 1 and this radius be 4, we can see that 1 plus 3 is 4. In other words, I increased the radius by 3. So I met that requirement. So what I'm going to do now is find the circumference for both of these. Again, circumference equals 2 times pi times the radius. Circumference equals 2 times pi. The radius in this case is just 1. Circumference equals 2 pi. Again, 2 times 1 times pi. In this case, again, we know we're dealing with the circumference, namely 2 times pi times the radius. we know the radius is 4, so we'll go ahead and plug that in. And I'm going to do 4 times 2, which is 8 pi. So we can see that when I increased this radius from 1 to 4, which is by 3, the circumference went from 2 pi to 8 pi. In other words, it grew by 6 pi, which is this answer choice here. Okay? If you didn't assign these numbers to these circles, you might have just guessed at this problem. Again, when they give you hypothetical questions like this, draw out the circles, meet the requirements in the question, and then you'll find your answer. Alright, number 3 says the supplement of a 30-degree angle is. So in this case, we have to know that there are 2 types of angles we need to be familiar with, namely complementary angles, which add to 90 degrees, as well as supplementary angles, which add to 180 degrees. 180 degrees is a straight line. Okay? So if we're given one angle measurement of 30 degrees, we know we can find the other angle measurement, which would be this one in this case, by subtracting 180 by 30. Again, supplementary angles add up to 180 degrees, which is represented by a straight line. If we're given one angle, we can always find the other. In this case, by taking 180 degrees, minusing 30 degrees. 0 minus 0 is 0. 8 minus 3 is 5. 1 minus nothing is 1. So we know this angle is 150 degrees, which is right there. Okay? If I'm not mistaken, later on in this practice test, there's a question about complementary angles, and we'll go ahead and be able to deal with that in light of the fact I just mentioned the 2 definitions. That said, number 4 says side A of a square measures 5 inches. What is the length of the diagonal? Okay, so we have a square, and as we all recall, every single side or length of a square is equivalent. So if this side is 5, this side must be 5, this side must be 5, and therefore this side must be 5. This question told us one side was 5, so we can fill in the rest of the sides accordingly. This question, in addition, is asking us to find the length of this diagonal. And if we take a look, when I cut the square in half diagonally, I form 2 right triangles. And I can use either of those 2 right triangles in the Pythagorean Theorem to find the length of the diagonal. So I'm going to go ahead and pull this square out right here, this triangle out right here. It's going to look like this. And this side's 5, this side's 5. This is the unknown side, which I'm going to represent as C, that we're trying to find. And according to the Pythagorean Theorem, we know a squared plus b squared equals c squared, where c is the hypotenuse and a and b are the legs of the right triangle. Of course, the hypotenuse can always be found because it's directly across from the right angle. In this case, I represent it as c, so we don't have to make any adjustments there. A and b are the same and interchangeable, so let's go ahead and fill those in. 5 squared plus 5 squared equals c squared. 5 squared, of course, is 25. 5 squared is 25 equals c squared. 25 plus 25 is 50 equals c squared. And as you work out these problems, try to keep your work very neat. Whenever I'm working out problems that require multiple steps, I always try to keep my equal signs in a vertical line as best I can. So we have 50 equals c squared. To get rid of this squared, I'm going to take the square root of both sides. This crosses this out. We're left with c equals the square root of 50. I'm going to bring this over here. Again, this is c equals the square root of 50, which I can split up to be this. C equals the square root of 25 times 2, which I can break up even further as this. Square root of 25 times the square root of 2. Of course, we know the square root of 25 is 5, and this times square root 2 is hanging out off to the side there, and that gets us our answer of 5 square root 2. Okay? Number 5 is a simple one-step equation. In other words, it's going to take us one step to solve this problem. It says if x plus 10 equals 7, then x is equal to, so we have x plus 10 equals 7. The goal of this problem is to get x by itself. To do that, I'm going to subtract 10 from both sides. This crosses out. We're left with x equals 7 minus 10, which is negative 3. Again, one step, which was right there. This is a very easy question. It's a very basic test of your knowledge of algebra. And you will see stuff like that on the ASVAB. Okay. Number 6 says if a cube has a volume of 64 cubic centimeters, what is the length of an edge? Now, I like to regard a cube as a three-dimensional square, in that all the lengths of the sides are equivalent. So if you know one length, you're going to be able to find all the other lengths. So this is my representation of a cube. To find the volume of the cube, you take one side, which I'm going to call A, and cube it. That is, you do width times height times depth, or width times height times length, or just one side cubed, since all those things are equivalent. So in other words, we want to find an answer choice. When it's cubed, that's going to be 64. So in other words, we want to plug in these numbers into A until we find one that is equivalent to 64. Well, 8 squared is 64, so 8 cubed is not going to be it. 6 squared is 36. 36 times 6 is going to be greater than 180. Earlier in this practice test, I actually had to work out 4 cubed, and if we recall, that was 64. Okay, 10 cubed is 1,000, so we know that's not the correct answer choice. Therefore, we know one of the sides is going to be 4, and we're able to solve this problem pretty quickly. I apologize if I sound tired. I did work for 9 hours today prior to making this video, so just bear with me in that regard. Number 7 says if 5/8 of a number is 30, the number is. So again, as we did with number 1, I'm going to try to write this out mathematically and solve it accordingly. 5/8 of some number x equals 30. Okay. Again, 5/8 of a number, which I'm going to represent as x, equals 30. So let's go ahead and solve this. To get rid of this 5/8, I'm going to multiply it by the reciprocal, namely 8 over 5. And what I do to one side, I have to do to the other. Okay, this crosses out. We're left with x equals. Again, you can make any whole number a fraction by putting it over 1. So if I wanted to make 5 into a fraction, I just put it over 1 to be 5 over 1. If If I wanted to make 10 a fraction, I can just make it 10 over 1. If I wanted to make 1,000,000 a fraction, I could just put it over 1. In this case, I want to make 30 a fraction, and I'm going to put that as 30 over 1. Now, prior to doing this math here, I'm going to reduce a little bit. I know 5 goes into 5 one time, and 5 goes into 30 6 times. Okay? So this problem becomes 6 over 1 times 8 over 1. Now we can actually do the opposite. Since this is over 1, we could just make these whole numbers. And 6 times 8, of course, is 48, which is right there. Okay? Let's go ahead and move on. Oh, let me reload that. I grabbed my pen too early there. Okay, what is the area of a circle that has a radius of 5 feet? Use 3.14 for pi. So, unlike the previous problem where we used the circumference formula, we're going to use the area formula of a circle, which is this. Area equals pi times r squared. Let's go ahead and make a little diagram if it's helpful. We're told the radius is 5 feet. Again, we have the area formula here, so let's go ahead and work this one out. Pi r squared is the formula to find the area of a circle. We know the radius in this case is 5, so that's going to be squared. We're told to use 3.14 for pi. And we know 5 squared is 25. So now we have to do 3.14 times 25, which looks like this. Now when we multiply a whole number by a decimal, we actually make this decimal into a whole number by shifting its decimal to the right however many times we need to. In this case, to make 3.14 a whole number, I'm going to move its decimal place 2 times to the right, and at the end of this problem, I'll add those decimals back in. So in reality, I'm working out this problem, 314 times 25, albeit with 2 decimals to shift back in to the left at the end. Let's go ahead and work this out accordingly. 5 times 4 is 20, carry the 2. 5 times 1 is 5, plus 2 is 7. 3 times 5 is 15. Since we're starting this 2, we have to add a 0 before we begin. 2 times 4 is 8. 2 times 1 is 2. 3 times 2 is 6. Let's add 0 plus 0 is 0. 7 plus 8 is 15. Carry the 1. 5 plus 2 is 7 plus 1 is 8. 6 plus 1 is 7. Shift our 2 decimal places back in. 1, 2. So we can see that the area, which is going to result in 3.14 times 25, is 78.5. Okay? Fairly straightforward problem. All right. Number 9 says, what is the mean of the numbers 15, 28, 50, 71, and 91? So this is testing our knowledge of some basic statistics, namely how to find the average or mean. To find the mean, I like to regard it as this. Mean equals some number. That is, the mean is the sum of all the numbers divided by the total number of numbers that there are. So that looks like this. Okay, there are all the numbers, and there's 1, 2, 3, 4, 5 of them. Again, the sum of all these divided by how many there are. I can't do this in my head, so let's go ahead and work that off to the side. We have 91, 71, 50, 28, and 15. 1 plus 1 is 2. 2 plus 8 is 10. Plus 1 is 15. Carry the 1. 9 plus 1 is 10. Let's see if we can do this easier. 9 plus 1 is 10. 7 plus 2 plus 3 is 10, so that's 20. That's 25. So we can see that this is equivalent to 255 divided by 5. Here's the trick. Anytime a number ends in a 5 or a 0 and you divide it by 5, it's always going to be even. So if this was 260 divided by 5, given the fact that this is a 0 and it's divisible by 5, I would be able to tell you this is going to be a whole number with no decimals. If this was 265 divided by 5, given that this is a 5 and it's being divided by 5, I would also be able to tell you this would divide evenly into a whole number. So if you ever see a number that ends with a 5 or a 0 and it's being divided by 5, it's always going to be a whole number. I know this is going to be a whole number, and again, we're going to regard this as long division, namely 255 divided by 5, which looks like this. Okay. We know 5 goes into 25 5 times, and 5 goes into 5 1 time. So 5 times 51 we know is going to be 255 with no remainder. Okay? So we know this answer is 51. All right. So number 10 is testing your knowledge of the order of operations, which is this. Please excuse my dear Aunt Sally. PEMDAS tells you the order in which to work out problems where there's conflicting information. That is, you start with parentheses, you move on to exponents, then you do multiplication and division from left to right, and then you do addition and subtraction from left to right. That is to say, multiplication and division are equivalent, addition and subtraction are equivalent, and as I said, you work those from left to right. In this case, we're going to start by working out the parentheses first, so let me go ahead and copy this over here so we have plenty of room to work with. Okay, so as I said, according to the order of operations, PEMDAS, we start with parentheses. So I'm going to go ahead and work out everything in parentheses. 5 plus 3 is 8. 6 divided by 2 is 3. 8 minus 1 is 7. 7 plus 3 is 10. We have an x hanging out there. So we did parentheses. There are no exponents for us to work out, so we can skip that. Now we do have multiplication. We have 8 times 3 times 7. We have 10 times x. So we're going to go ahead and work on multiplication. 8 times 3 is 24. 24 times 7 I can't work out in my head, so let's work it off to the side. 24 times 7. 4 times 7 is 8. Carry the 2. 7 times 2 is 14, plus 2 is 16, so we can see this is 168. 10 times x is just 10x. Now we're trying to solve for x as it tells us here. So I'm going to divide both sides by 10 as my next step. This crosses out. I'm left with x equals 168 divided by 10. Whenever you're given something to divide by 10, 100, 1,000, or any number that ends with 0 or is a power of 10, you should be able to do it in your head because as I've explained in most of my videos, when you're doing division by 10, 100, 1,000, a million, and so on, you shift the decimal place to the left however many times there's a 0 in this number. So in 10 there's 1 0, and remember that decimal is sitting right here. So 168 divided by 10, you just shift this decimal to the left 1 because there's 1 0. So we know that's going to be 16.8 equals x, which is right there. If this was 168 divided by 100, again, the decimal place is technically right there. We have 2 zeros by which we're dividing. So we're going to shift this 1, 2. So we know this would be 1.68. Okay? If this was 168 divided by 1,000, again, we have 3 zeros. It's a power of 10. Decimals here, we shift it 1, 2, 3. This would be 1.68. Again, you have to be able to do little tricks like that to save yourself time. So if it's 10, 100, or 1,000, just remember you're shifting your decimal place left and right accordingly. Alright, I gotta get rid of my pen to move on. So earlier we did a problem that asked us, that tested our knowledge of supplementary angles. Number 11, as you can see, is going to test our knowledge of complementary angles. It says if angle A is 5 times its complement angle B, what is the measurement of angle A? Again, there are 2 types of angles with which you need to be familiar, namely supplementary angles, which add to 180 degrees, and complementary angles, which add to 90 degrees. So in this case, we know we're dealing with complementary angles, so we know they're going to add to 90 degrees, which is a right angle. Specifically, we're told that angle A is 5 times as big as angle B. So let's just call this x angle B. And if x is angle B, we know A is 5 times angle B, so that's going to be 5x. Again, we can call this angle B, angle A. And again, we're just taking the information we're given, making a little diagram, and now we can actually solve the problem. Again, we know that complementary angles add up to 90 degrees. So in other words, x plus 5x is going to be 90 degrees. X plus 5x is 6x. That's going to be 90. Divide both sides by 6. Okay, that crosses out. 90 divided by 6. In case you can't do this mentally, let's work it out. Again, 90 over 6 is the same as 90 divided by 6. 6 goes into 9 one time without going over. 6 times 1, of course, is 6. 6 minus 9 is 3. We drop down this 0. 6 goes into 30 5 times without going over. 6 times 5, of course, is 30. So we can see there's no remainder. So we can see x is going to be 15 degrees. We want to find the measurement of angle A. We know x represents angle B, which is 15 degrees. And angle A is 5 times angle B. So we can do 15 times 5. 5 times 5 is 25. Carry the 2. 5 times 1 is 5, plus 2 is 7. So we know this is 75 degrees. And therefore, that's our answer. Again, 75 plus 15 is 90 degrees. Okay, so just using our knowledge about complementary angles and some very basic algebra, we can solve this problem pretty easily. Let's go ahead and move on to the next problem. Again, this is one of the easier practice tests on the website. Number 12 is testing your knowledge of the laws of exponents, specifically what you do when you multiply exponents together. That would be this rule: a to the n times a to the m times a to the o. Whenever you multiply exponents that have the same base but different exponents, you simply just add the exponents. So this would become a n plus m plus o. Okay? You can see that we have that case here. So this is going to become x 4 plus 5 minus 3. 4 plus 5, of course, is 9 minus 3. 9 minus 3, of course, is 6. So we know our answer is going to be x to the 6th power. Okay, just testing your knowledge of the laws of exponents. And you may have noticed that for every problem in this section, you kind of have to know a formula, a law, or some sort of definition to solve the problems. That's the difference between arithmetic reasoning and mathematics knowledge. Mathematics knowledge requires you to know formulas, definitions, and laws, whereas arithmetic really focuses on your ability to do addition, subtraction, multiplication, and division with decimals and fractions. Okay? Key difference there. 13 says, what is the volume of an aquarium that measures 18 inches long, 8 inches wide, and 12 inches high? So let's go ahead and sketch this. Again, we're dealing with a rectangular prism, which kind of looks like this. This is the fish tank. We know it's 18 inches long, 8 inches wide, which is this one right here, and 12 inches tall. So we need to find the volume of it. So the volume of a rectangular prism, we have to know its formula. It's length times width times height. So let's go ahead and plug things in. The length, of course, is 18. The width is 8. And the height is 12. I can't work this out mentally, so let's go ahead and work it out to the side. 12 times 8 is 8 times 2 is 16, carry the 1. 8 times 1 is 8, plus 1 is 9. So this is 18 times 96. Let's go ahead and work that out. Again, take your time here so you don't make any mistakes. 6 times 8 is 48. Carry the 4. 9 times 8 is 72. Plus 4 is 72, 73, 74, 75, 76. Since we're starting this 1, we have to add a 0 here before we begin. 1 times 6 is 6. 1 times 9 is 9. Let's go ahead and add these together. 8 plus 0 is 8. 6 plus 6 is 12. Carry the 1. 7 plus 9 is 16. Plus 1 is 17. So we can see the volume is going to be 1,728 inches cubed, since we're dealing with volume. These say square inches, which is wrong. Should be cubic inches. So that's my bad there. But 1728 is the correct answer. Alright, this is probably the toughest problem on this practice test, in as much as it is not something you can solve, in as much as I put something in there to intentionally frustrate you. Okay? So we're given this right triangle and we're being asked to find its perimeter. To find the perimeter of anything, you simply add up all the sides. A triangle has 3 sides, so it'd be side 1 plus side 2 plus side 3. The problem is I didn't give you side 3, so you have side 1, 15, plus side 2, 17, plus side 3, which you don't know. Okay? So in order to get this unknown side, you have to use the Pythagorean Theorem, which, as I mentioned earlier in this video, is a squared plus b squared equals c squared, where c is the hypotenuse and a and b are the legs of the triangle. Of course, the hypotenuse is always across from the right angle, and the legs are interchangeable. So to find side C, which I represented as the unknown with the letter C, we have to plug in our legs to this equation. So we're going to do 15 squared plus 17 squared equals C squared. Okay, I'm not going to work out 15 squared. You should know a lot of your squares up to about 15. 15 times 15 is 225. Right, 255, 225. 17 squared, I'll go ahead and work out. 17 times 17 is 17 squared. 7 times 7 is 49, carry the 4. 7 times 1 is 7. Plus 4 is 7, 8, 9, 10, 11. Add a 0 since we're starting this 1. 1 times 7 is 7. 1 times 1 is 1. Let's add. This is 0 plus 9 is 9. 7 plus 1 is 8. And 1 plus 1 is 2. So this is 289 equals c squared. Let's go ahead and add those together. Again, that's 225 plus 289. Okay, 5 plus 4, or 9 plus 5 is 14. Carry the 1, and let me do this somewhere else since that's hard to see. 225 and 289. 5 plus 9 is 14. Carry the 1. 8 plus 2 is 10. Plus 1 is 11. Carry the 1. 2 plus 2 is 4. Plus 1 is 5. So we're left with 514 equals c squared. Now we're going to take the square root of both sides to get rid of this squared. This goes away. We're left with c equals the square root of 514. Now if you've gotten this far, you're probably saying, how do I find the square root of 514? Well, the trick is not to find the square root of 514. Rather, the trick is to estimate it. Okay, so I know 20 squared is 400. And I also know 25 squared, which I can do very quickly. 5 times 5 is 25. Carry the 2. 2 times 5 is 10 plus 2 is 12. 0. 5 times 2 is 10. Add a 1. 2 times 2 is 4 plus 1 is 5. Also know 25 squared is 625. So we know the square root of 514 is going to be somewhere between 20 and 25. So if I wanted to estimate this answer, I can plug in, let's say, 23 as my C, and then use that to find the closest answer choice. Now if I wanted to whittle this down even further, I can find what 22 squared is. 2 times 2 is 4. 2 times 2 is 4. Add a 0 since we're starting this number. 2 times 2 is 4. 2 times 2 is 4. 4 plus 0 is 4. 4 plus 4 is 8. 4 plus nothing is 4. So 22 squared is 484. And let's find 23 squared, because we know 514 is bigger than 484. 3 times 3 is 9. 2 times 3 is 6. Add a 0 since we're starting this number. 2 times 3 is 6. 2 times 2 is 4. Let's add. 0 plus 9 is 9. 6 plus 6 is 12. Carry the 1. 4 plus 1 is 5. So 23 squared is 529. So, in light of the fact that c is equal to the square root of 514, I know c is going to be 22 point something. Again, 23 squared is 529, which is too big. 22 squared is 484, which is small. So, in light of the fact that 514 is in between those, I know my c is going to be 22.x. So I'm going to go ahead and plug it in accordingly. This is going to be 15 plus 17 plus 22.x. Let's go ahead and add these up. And again, this problem does require a little bit of work. Let's work that out right here. 15, 17, 22.x. I know for 100%, that c is 22 point something. Neither 15 nor 17 has a decimal, so I know this whole number that I get on this side of the decimal is going to be the correct first part of this answer, and this x is going to be irrelevant in many cases. So 0 plus x is just going to be x, so we know it's going to end in some decimal there. 5 plus 7, 7, 8, 9, 10, 11, 12, plus 2 is 14. Add the 1. 2 plus 2 is 4, plus 1 is 5. So I know this perimeter has to be 54 point something. And instead of working this out, which would take me a long time, I'm going to look at the answer choices and see if one of them is 54 point something, some decimal, and I'll know without doing a tremendous amount of work that I've found the answer choice. Let's see. And there we have it. 54.7 is the correct answer choice. And I solved that pretty much by estimation. Again, this is 48, 61, 65. We know that 54 is correct, and we knew there was some decimal hanging out there. So you don't always have to do the tedious work to get the right answer. Okay. 15 says convert 6.39 times 10 to the 4th to standard notation. So that's 6.39 times 10 to the negative 4th. The way you read this is anything times 10 is going to shift the decimal place, as I mentioned a little bit earlier in another problem. And since this is negative, we know it's going to shift the decimal place to the left 4 times, which looks like this. 1, 2, 3, 4. Add our zeros in those gaps. 1, 2, 3. So we know this is going to be 0.0000639, which is answer choice D. Okay. If this was 6.39 times 10 to the 5th, again, we would recognize that this times 10 to the 5th simply is going to be shifting the decimal place 5 times to the right. So this would look like this. 1, 2, 3, 4, 5. Add your zeros in the gaps, and it would be 639,000, and you'd be done. Okay, final problem coming up. All right. 16 says, what is the sum of the angle measures of a pentagon? A pentagon has 5 sides, 1, 2, 3, 4, 5. And we want to find out what the sum of all the angles, interior angles are. So we just have to know this formula. The sum is going to be, what is it? 1/2 of 180. Nope. sorry about that. Even I forget this formula sometimes. The sum of the angles is going to be 180 times n minus 2, where n refers to the number of sides in the figure. Again, we know a pentagon has 1, 2, 3, 4, 5 sides, so that's going to be our n. It's going to look like this. 180. N again is 5, the number of sides, minus 2. 180 times 5 minus 2 is 3. 180 times 3 is 3 times 0 is 0. 3 times 8 is 24. Carry the 2. 3 times 1 is 3, plus 2 is 5. So the sum of the interior angles is going to be 540 degrees, which is right there. If you ever forget this formula, which I just did, and it happens, always think of a triangle. A triangle, you should know, always has interior angles that add up to 180 degrees. So again, I like to think of a triangle when I'm thinking of this formula. Triangle also has 3 sides. So the sum of the interior angles of a triangle is 180, 1, 2, 3 sides. So that's going to be our n minus 2. 180, 3 minus 2 is 1. 180 times 1 is just 180. So you can see that the formula works for all shapes, including triangles, pentagons, and so on. So that's all I have for you in this video. As I said, I made it after work today, so in some cases I was a little bit tired and may have misspoke. That said, I hope you found it helpful. In the future, I'm going to post the solutions to the mathematics knowledge subtest for the second and third practice test. I'll probably do that later this week. As always, feel free to leave comments in the comments section below. Please share my content with friends if you found it helpful. But on that note, I'm going to go ahead and cut you guys loose.